Okay, your first video, math stats. I'm going to try to not sound like a Yankee, but it probably won't happen. Also, my son is bringing me some McDonald's, and so I will probably have to pause this soon so that I can eat my fries. I mean, salad. Okay, here we go. So, we learned expected value on Wednesday. And you're going to use that skill and add on to it so that you can find the mean and the standard deviation when you have a continuous function. So we do mean and standard deviation in my regular stats class, but that's when we don't have a formula that we're working with. So when you have a formula and a continuous expression, then you've got to use some other things to find mean and standard deviation. By the way, I'm going to write in here variance as well, because you have to find the variance first to find standard deviation. There's symbols for all these things. In stats, the symbol for mean is the Greek letter mu. Standard deviation has the lowercase Greek letter sigma. Variance is just the sigma squared. It's just when you're finding this, you have to first find variance, and then you take the square root, and that's how you end up with standard deviation. So variance kind of has its own symbol, but you never use it by itself, so it's kind of goofy. In stats, you already know how to find the mean, the expected value, which is what we learned on Wednesday and what you did for homework. The expected value is the mean. So that makes sense. I mean, if you're talking about, like one of those examples was talking about tread wear on a tire, the expected value is how many miles you should expect to get, which is the mean. You should always expect to get the mean. Some people get more, some get less, but so that's the equivalence there. So all you need now is the formula for finding the variance, because once you have the variance, all you have to do is take the square root, like I said, to find standard deviation. So let's talk about that formula. Okay, so it's the expected value of, instead of x squared. And we kind of talked about it. We had an example in class on Wednesday where we said, you know, whatever's in these parentheses here, that's what you're going to multiply your function by. So when you're doing just regular expected value, you multiply x times your function. If it says x squared, you do x squared. So you're going to do the expected value of x squared, and you're going to subtract the expected value of just x, so that's the mean, only you're going to take that expression and square it. And no, these don't give the same value. It looks like they will, but they won't. You could take, well, anyway, we won't get into that. So that's the formula right there, and that gives you the variance. And so if you want the standard deviation, you take the square root of the variance, and then that gives you your standard deviation. Standard deviation, I'll make my stats students calculate it by hand when we have a bunch of numbers, but a standard deviation tells you on average how far away from the mean are most people. That's what a standard deviation is. So a standard deviation of 10 on a test would mean most people are within about 10 points from the mean. So that's what it tells you. Okay, so the problems take forever because, I mean, you remember how long just expected value problems are. Well, now you're going to do expected value, and then you're going to square that. Then you've got to do it again, only this time where you're plugging in x squared instead of x. Subtract the 2, and then take the square root. So let's get at it. Let me scoot this up. Okay, I'm going to do a couple basic examples, and then I'm going to do one that's integration by parts. And then I think I have I have 5 problems that I want you to do for homework. So the first example is if we have a probability density function that looks like that. 2 times 1 minus x. That's defined for where x is between 0 and 1. And it's 0 elsewhere. Okay, that's our function. And we want to find, let's say I want to get all the way to the standard deviation. Okay, which means I got to do that whole thing right there. So let's get at it. Expected value. This is what we did Wednesday. So who was absent? Ned. I think that was it. I'm going to feel bad if I forgot somebody. Okay, anyway, standard deviation. So expected value goes like this. We're going to do the integral of whatever our function was, which is 2 times 1 minus x, multiplied times x. And then we're going to integrate it, and we use whatever our boundaries are. In the original problem, that's where you're going to set right there. So we're going from 0 to 1. That's what we're going to evaluate this by. Okay. I want to clean this up, do the normal thing we do. I want to, holy monkeys. All right, so I'll bring that 2 out. Good gracious. Bring that 2 out. 1, 0. Distribute my little x in here, so I have x minus x squared. So go ahead and that gives you x squared over 2 minus x cubed over 3. And then I'm going to, gosh, I got to write smaller if we're going to have room. I don't know if I'm going to run out of room or not. I guess we'll find out. Distribute my 2. So multiply both of those times 2. The 2's cancel. I have x squared minus 2/3 x to the 3rd. I'm going to go ahead and apply my values of 1 and 0. When I plug 1 in, I get 1 minus 2/3. When I plug in 0, I get 0. So I get an expected value of 1/3. So that is the mean. Or in symbols, that's the expected value of x. And so now I've got to square that. So I do 1/3. So if I want to square that, I have to square my 1/3, which gives me 1/9. Okay, so that's the second part of the formula. I have to do all that over again, only I have to do the expected value of x squared. So we're going to take the same function, only now we're going to multiply it times x squared. So I'll try to kind of rewrite that. The disadvantage is when you're moving stuff around, we can't really go back to it like the other ones, like we can in class. So I'm going to rewrite the formula up here where we can see it. The expected value of x squared minus the expected value of x, only that quantity squared. That gives us the variance. That's what we're working on, and then we're going to take the square root. All right, so let's do the expected value of x squared. So this time I take x squared times that original function, which was 2 times 1 minus x. Our original boundaries are from 0 to 1. So again, cleaning up, I'm going to take that 2 out and distribute my x squared. So that gives me x squared minus x cubed. And then I'm going to do my calculus. And I'm going to have x cubed over 3 minus x to the 4th over 4. Then distribute that 2 to everybody. So I have 2/3 x cubed. 2/4, I'm going to go ahead and reduce that to 1/2 because I feel like it, doggone it. Go ahead and apply your 1 and 0. Oh, I got to do it in parts. So you guys go there, you go there. And I get 2/3 minus 1/2. Get a common denominator there. You got 4/6 minus 3/6. So that gives me 1/6. So if I plug it into the formula said expected value of x squared minus expected value of x, that quantity squared, that gives me the variance. So I have those things. So my expected value of x squared is 1/6. From the previous screen, my expected value of x, only that quantity squared, was 1/9. Remember, we got 1/3 and we squared it. Common denominator, 3/18 minus 2/18. So we get 1/18. That's our variance, but I asked for standard deviation. The last thing you have to do is take the square root of that. A lot of these we leave in, your book is leaving in decimals. So I guess we'll go ahead and do that. So the square root of 1 divided by 18 would be 0.236, I guess, if we round to 3 decimal places. And that gives us standard deviation.